Okay, so this very first video in regards to IR is about how to prepare a solid sample. So in preparing the solid sample, what you first need to do is you'll come over here to where we have our scale. And what you need to measure out first, and I have it well labeled kind of on this Erlenmeyer flask, is you need to measure out 1 milligram of your sample with 100 milligrams of the KBR. I have it written here because that's one of the most common questions I get asked all the time is, wait, remind me again how much I have to weigh out, so I have it here. I try to always keep like a spatula here, and I'll probably bring in more. Where the KBR is always kept is inside the desiccator. So the KBR is a salt, and if it's not inside the desiccator, then it's just going to absorb water from the air, and eventually we'll just end up with kind of a salt water solution if we have a humid enough day. So then the very first step is to go ahead and measure out the KBR, your sample, and they really can all go into the very same like weigh boat. As long as you're pretty careful in measuring and you don't go too far outside the 1 milligram and 100 milligrams. I usually literally do just put it into the same weigh boat. And it doesn't have to ever be 1 milligram exactly. Even going up to 2 is fine. And it doesn't have to be 100 milligrams of KBR exactly. Going up to like 150 can be fine. 200 and you're getting almost a little bit too much KBR. Okay, so then the next step of the sample, so I'm going to grab the sample that we've already made. So then the next step is, I have such good camera skills. Actually, would you mind holding it in place? About right there. Okay, so then the next part is to go ahead and take the sample, put it into this mortar and pestle, and then grind it up very finely. And it really does need to be this small mortar and pestle setup. So this mortar and pestle is made with very fine material so that we can grind very finely. In the lab, there's all different kinds of mortars and pestles, but these are the best for this sample preparation. And the better you grind it, the better data you usually end up getting. Now, I wouldn't spend, like 5 minutes grinding everything up, but I would go ahead and spend a good, about a minute making sure that it's all finely ground. Actually, since the sample was very dry, which is important, this is actually grinding up very nicely, so I'm not going to need my whole minute. Okay, so now for the next step, we need to take the sample over to our sample preparation area. So if you want to follow me with the camera. Okay, so sample preparation. Do you mind holding the camera? It almost has to be held up above at this point. Okay, so to prepare our sample, what we have to do is we have to make our own salt plate. So the liquid samples, as has already been demonstrated to some people, the liquid samples are held in between 2 already prepared salt plates. And instead, what we have to do for this solid sample is we have to make our own salt plate. So we are making a very small plate, and actually it's technically called a pellet, and it's going to have the sample embedded within the pellet. The reason why we use salt is because it is not IR active, because we don't even have a covalent bond. All of the bonds are ionic. So then therefore the only IR active covalent bonds are going to be in our sample. Okay, so how we make our salt pellet is in this way. We have to put together an assembly, and I keep all the parts of the assembly in this large desiccator, again because that keeps everything just pretty nice and dry since we're working with salts. So we have a bottom piece. I usually refer to anything at the bottom like as being the stage, for lack of a better term. And then what we have to put on top is this piece, and we're going to build our pellet inside. So to build our pellet, we are going to press our solid material in between these 2 little metal plates. And on the metal plates, there is one side that is completely flat and one side that is rounded. and we need to build our plate between the flat and the rounded. So I'll come around so you guys can see. Can you see how one side is completely flat and one is kind of rounded? So it looks like that. One is flat, one's rounded. And so then that means our first piece that goes in is going to go in rounded side down. And sometimes you need to go ahead and use a spatula to kind of press it down to the bottom. And then the next step is to go ahead and get our sample into the press. And as long as you get a majority of your sample and KBR in, that's fine. It's not as if you have to get every last little bit. And then what I think is important is to go ahead and take like 30 seconds or a minute to kind of distribute the sample around the sides. You don't just want this clump directly in the middle. Otherwise, you're not going to end up with a very smooth plate. So I have no idea if the video, do you want to see if the video can even see inside there? Oh, kind of, yeah. So you can see that it's fairly well distributed across the bottom, but don't spend too much time working on this. So then the next thing we need to put in the top plate. So now it needs to be flat side down so that we're building our plate in between the two. I'm going to clean off the edges a little bit. Since this is a pretty airtight system, that means that when we place this on the top, it would take a while for us to wait to have that top piece fall down. So you can see it slowly falling down. It is fine to go ahead and help it. So I like to go ahead and just press on it. And you can press on it either just with the spatula, or we actually have, oh, it fell through the desiccator. A little inconvenient. There we go. So we have this press, that piece right there. So you can also use it to press it down. Okay, and actually our complete assembly is like this with this final piece into the top. So now at this point we have prepared the press, and now we need to put the press into this guy. So now what we do is we have the whole press assembly inside, and I like to go ahead and close the door. We've never had any accidents where something has blown up on the inside, but you just never know. So then the next step is to just go ahead and start applying a load. First, what has to happen is the stage gradually raises up. And then once the stage gets to the top, then that's when you have to start pressing down. And it takes quite a bit of work. We need to get to about 7 metric tons. And then when we get to 7 metric tons, so you can see the 7 across the top, then we wait usually for about 3 minutes. That's going to be for the best pellet. We wait about 3 minutes. So all together we can sing happy birthday 6 times through for the video. Or maybe not. I guess I should have thought ahead, and while we wait our 3 minutes had like a chemistry joke to tell for anyone watching the video, or maybe just fast forward.
So it's rounded side down and then
Correct.
Rounded side
up. Right.
So it's between the two flat sides.
Correct.
Okay.
It's between the two flats. And that's so that you get the best application of pressure through the middle. And so we're under this pressure, we're just solidifying that salt, and we're making it into a nice clear crystal. So that's what happens. So you can kind of think of this as being about the same way that diamonds are made. So you take your black graphite, put it under the high pressure, and when you form these very ordered crystalline forms, then they're a little bit more see-through. Okay, so we're going to call that as being at about 3 minutes. So the next thing that we need to do is release the pressure. So it's righty-tighty, lefty-loosey, and so we turn the knob to the left so it releases the pressure. I'm going to go ahead and open the door. And the best thing to do is only allow the stage to fall just enough to where you can get the assembly out. Don't let the stage fall all the way to the bottom. So a couple reasons for that is then the next person doesn't have to, apply so much work in order to get the stage back up. And then also if the stage does fall all the way to the bottom, this is an old enough piece of equipment that it likes to stay there. It's really hard to convince it to start working again. So both Bob and I have tricks. So I think Bob kicks it and I wiggle it. So we have tricks to get it working again. So if it's ever not working, then you should come get either Bob or I, and we can get it back to work. So this is great for the video. So this is a piece of, this is a magnetic surface, and so it does take just a little bit of work to pry it off of the top. And so now we need to set our pellet free. Now this is where it would be good if I had like several takes of a video, because setting the pellet free without breaking it is not an easy thing to do. So we've just created that pellet under 7 tons of pressure. We have to use pressure to break it out of the assembly, but not so much pressure that we break our little piece of salt crystal in pieces. So let's see if it turns out for me this time. Since most of the time you all are now creating your own pellets, I actually don't have as much experience as I used to have. So what I usually do is I have this little piece of foam that I often work with, and you may find ways that work better for you. And then I like using this stage to then put this assembly on top of. And now the trick is, well, for me, I try to carefully press down. Oh, I'm not sure that it actually went, because that didn't take quite as much work to set it free. Let's see what it looks like. Don't break. Oh, actually, it's not bad at all. There we go. So that works pretty well. What really helps is if everything is fairly clean, then all of the parts will slide against each other better, and we do have a little bit better salt plates that are formed. So that's what the salt plate looks like. So that ended up being pretty good salt plate. You only need, a piece that is small enough to fit into the IR. So it doesn't have to be a pure circle. You can sometimes get even small pieces to work, but this is going to work really well for us. So now let's go ahead and get this into the IR for analysis. What we use are these little holders. So I have a couple of them in here. So then that way, kind of as one group is analyzing, another group can be making their pieces. And I sometimes just like this one because it kind of already has that hole in the center. So now here also is like a delicate part, is making sure that you don't break your pellet as you go to put it onto the holder. So I just kind of carefully orient it into the center. These are my own homemade pieces of magnet. And I have them in 2 pieces, because then that way if you're trying to be really creative to hold a really tiny piece in the middle, you could like try to orient them in all different ways. And so now we need to place this into the instrument. But before it goes into the instrument, what we need to do first is kind of take out any adapter that's already here. So there is already adapter for the liquid sample, so I'm going to set that to the side. And then also we need to go ahead and take a blank, because it's important to background subtract any of the data, so we should take a blank. So there happens to be data that is on the screen right now, and so what I'm going to do is I'm going to go ahead and come over here to the selection tool, and then I'm going to click on the data that's already on the window, and then I'm going to hit clear, so then that data is gone. Now I'm going to collect a background, so I select the collect background icon. It says prepare. It's prepared because it's completely empty in there, so I hit OK. And I have it collecting 4 scans, and that's about all that you really need to have it collect, is the 4 scans. So we don't want to add to window 1, so it says add to window 1, and I'm going to select no. But before I do that, I want you to see that this is actually a very normal looking background. So our background is going to have peaks because we have lots of chemicals in the air and they are going to absorb some of the IR. This very significant peak is CO2. So it's the carbon dioxide. And so we see that always very prominent in any background. So I'm going to clear away the background, and now what I'm going to do with the sample is I'm going to take this holder, I'm going to put it into the groove, slide it down, and again, this doesn't need to be closed at all, it can just remain open. And now I'm going to hit collect sample. It always asks for a name, so you gave your first one a name, right?
Yes.
What would you like to call this? Okay, I'll let you go ahead and type in the name. It's prepared because it's in there, so you can go ahead and hit OK, and now it's collecting the sample. There, and we have good data. So now we do want to add this to window 1, so we can select yes. At this point, it's great to start adding data. So to add data, you come down to the text tool and then you can start highlighting peaks. So let's say this one looks like a pretty major peak. So I can click on the peak, I'll drag it out to the side. So it says 1601. Is that a peak that seems like it'd be something you'd want to interpret? Yes. So then you can go ahead and hit enter, and then that places it on the screen. I can come over here to this one. What about 1691? So that's getting to that carbonyl. And then we seem to have another one right here. So 1725, that's looking like another kind of carbonyl. And it makes sense because I think on this compound we do have 2. But you can look at the data and see if it makes sense or if it's contaminated with a little bit of your starting material. So we wonder, okay, what might be going on here? So that is 2549. Is that a peak that we're really interested in? It's not. And so then you can just hit delete and then enter, and it does not mark that peak. So then what about this one? Yep, so that's 29, so that would be below 3,000, so those sp3 carbon hydrogens. Yep, 2962, let's see what this is. Oh wait, I'm reading it upside down, it's 26. So then here's the 28. So maybe we're not all that interested in the 26, and so if you end up marking something but you don't really want it, then you can click on it. It will bring up that number again, delete, enter, and then that mark is gone. So then can come over here. So then this is a little bit above 3,000. Kind of seems like we might have some alcohol character. So that would be at about 34. So I think that small, like more of a hump rather than a peak is worthwhile noting just to see if it makes sense when you go back and look at your starting materials ending product. So at this point you have the data, it's all marked. A couple of things you can do with it. So the first, you can go File, Save As, and then you can choose to save it as a TIFF file, and then you can save to your own H drive. Not all operating systems are compatible with TIFF, so it depends. And if you're not sure about your operating system, then there's a couple of things that I do. So, well, actually it's what I do, which is I print the screen, and then if you have a Word document open, and we happen to already have one open, then what you can do is you can come into your Word document. I need to come down here, and then we can go paste, and then it drops it into the Word document. And so then if you're running several IR, then you can create one document, save it to your H drive, share it with your lab partner, and then it can be this document that you then upload to Lab Archives. So that's how you can work with a solid sample.
What's the print screen?
So the print screen, actually for this keyboard, it literally has it. It does literally say print screen. Most PC computers do have that option. Okay, so that is the end of our first video.